This is lesson 4 of the review expressions and formulas. So we're going to be comparing formulas and expressions here. Formula might not necessarily be a new word for you, but you might think of it more as an equation. But basically, we're just going to compare them and look at a couple examples for this lesson. So looking at the equation or formula column here first. So an equation is a sentence. And we call it a sentence because it usually has the verb is or equals in it. Okay, so when you have an equation, you're solving. Okay, and these equations always have an equal sign. So it has an equal sign. Versus an expression. So an expression is more of a phrase. Okay, which means there's no verb used. So when we're looking at expressions, we're simplifying them. We're not actually able to solve. The most we can do is simplify. And these ones do not have an equal sign. So it has no equal sign. All right, so let's look at a couple of examples here to kind of really gear down on what the difference between these two is. So again, looking at the left-hand side here, these are our equations. So an example of an equation here is 10 is 5 less than a number. Okay, so we can see it has that keyword is, right? Which we know means equals. So if we were to actually write this using numbers, 10 is, or 10 equals, 5 less than a number. 5 less. So we know we're going to have to subtract, right? We're going to subtract 5 from a number. And a number we can just represent with a variable. So x minus 5. Okay, and that is an equation because it has that equal sign. If I asked you to solve for x here, you would be able to do it, right? The next example says 5 more than a number equals 7. Okay, again, it has that keyword equals. So 5 more than a number. 5 more. So a number, another way to kind of rearrange that, a number plus 5 equals 7. And again, we have our equal sign. This is an equation. We can solve it. Okay, so the value of a variable, okay, which again is just basically a letter, an unknown, is found, like I said above, by solving the equation. All right, so before we actually go into that, let's go back to this expression side here and look at some examples. So a number less than 5. A number less than 5. Okay, so another way to write that is x minus 5. Okay, x, a number less than 5. Oh, I'm sorry, I mixed these up. So a number less than 5. And these are honestly kind of confusing when it explains them in the words like this. But a number less than 5 is actually 5 minus x. Right? A number, x, less than 5. Whereas 5 less than a number is where that x minus 5 would come in. Okay, so we can see that these have no equal signs, right? They do have variables, but we can't solve them because there aren't any equal signs. So instead of solving these expressions can be evaluated by substituting. A value for the variable. Okay, so now let's look at some examples. We'll stick with the expression examples first because that's what we just talked about. So you can't solve these expressions unless it gives you a value for x to sub in. So in this first example, it says if x equals 2, evaluate 5 minus x. Okay, so all that means is we're going to replace the x with the number it gives us, in this case 2. So 5 minus 2, okay, which we can simplify, right? That's going to equal 3. Same thing here. If x equals 1, evaluate x minus 5. Okay, well again, instead of writing x, we're just replacing that with what it tells us. So that's 1 minus 5, which is negative 4. Okay, so those are pretty easy, right? Substitution. And you learned that in grade 9. So it might not be super fresh, but I'm sure it'll come back to you. It's not too difficult. Okay, whereas if we have an equation, it won't tell us to substitute because we can simply solve with the information we're given, right? So in order to do that, we need to rearrange this equation so to isolate x. So x is all by itself. So in order to do that, I need to get rid of this negative 5. Okay, again, you can think of it in two different ways. When I move it over the equal sign, it changes signs, so this negative will become a positive. Or you can think about it as getting rid of it. In order to get rid of a negative 5, we'll have to add 5 to each side. Okay, either way, however you want to look at it, our next line is going to say 10 plus 5 equals x. Okay, and then we're just simplifying, right? 10 plus 5 is 15 equals x, and we're done. Okay, you're done solving an equation when it says x equals a number. All right, so let's look at this next one here. X plus 5 equals 7. Again, same thing. We can think about moving this 5 over the equal sign, changing its sign, or we can think about subtracting 5 from each side so that they will cancel out. Either way, you're going to be left with x equals 7 minus 5, x equals 2. Okay, so in this case, on the left side, when we're looking at equations, we're going to have x equals something, whereas on the left side, we're going to just be left with a number. So let's look at a bit more confusing examples, a little more tricky here. So the first one says simplify, okay, and it has this long thing. So you'll remember like terms, okay, and collecting like terms. So we can only combine terms if they have the same variable. And I'll just make a note of this. Again, you've learned this already, just remember. Same variable and same exponent. Okay, that's the only way you can combine these terms. So the first thing that you might want to do is rewrite this where those like terms are next to each other. Okay, another thing you can do is you can underline in different colors, you can circle, you can square the like terms. When you are doing this, remember it's important that the sign in front of the number or the variable is attached to it. So this first one here, negative x squared, that negative is attached to that x squared. So what I'm going to do is I'm going to use orange and I'm going to underline every term that has x squared. Okay, so there's just the two. Now I'm going to move on. I'm going to look at the x. Okay, so I have one x there, and that's it. Okay, again, you don't have to use colors. You can be boxing, you can be circling. You might not even need to do that. Now I see I have a y squared term, and I go and there's another y squared, remembering that that negative is attached to it there. And lastly here, I just have my integers or my whole numbers. Okay, so I've kind of color-coded that. So maybe instead of rewriting everything out again, because I have everything color-coded, I'm just going to go right to simplifying. So when we're simplifying, we're just simply dealing with the coefficient. So we have negative x squared plus 3x squared. Okay, so remember when there's no number actually showing, it just means that there's an invisible 1 there. Okay, so we have negative 1 plus 3 is essentially what we have. Negative 1 plus 3 is 2, remembering that those are our x squared terms. Okay, now we move on to this yellow. I only see one yellow, so I'm just going to rewrite that. Plus 2x. Okay, now I have my green, my y squared terms. I have negative or minus negative 2y squared, okay, minus 6y squared. So you can see we have this double negative here. So this is the same as just adding, right? So just the same as adding. So this is actually positive 2 minus 6, which is going to give us negative 4y squared. Don't forget to bring along that variable in the exponent. Okay? Now I'm going to look at, I'm actually going to skip. I'm going to look at my orange term here. Just because proper, oh wait, never mind. I've already dealt with the orange term. All I have left here is my purple. And another thing that you might want to do as you're going is just crossing those out as you finish them. Okay, so we dealt with our x squareds, we dealt with this yellow, and we've dealt with the green. So all we have left now is our purple. Okay, and those are just integers, so that's even easier than what we've done before. So it's negative 5 plus 9, okay, which is just going to give us positive 4. We've simplified this as far as we can go. The reason for that is because we no longer have any like terms, right? And I'm just going to make a note. So this is, if you're writing this down, like terms. Okay, so an x squared cannot be combined with an x. A y squared cannot be combined with an x squared. So we're done. Okay, that one is complete. Moving on to example 2. Find the value of this expression, okay, if x equals negative 2 and y equals 3. Okay, so this first one here was an expression, right, because we had no equal sign. Second one, still an expression because we're using substitution. Again, substitution means when you see an x, you get rid of it and you put in a negative 2. When you see a y, you simply get rid of it and put in a 3. So I have 2, and I'll put my substitution in a different color here. So now I have x squared. So I'm going to get rid of my x and put in negative 2. Okay, you're going to want to put it in brackets so you don't make the mistake of like adding or subtracting those numbers. Okay, keep the squared plus another x, so negative 2, and a y, so 3, minus another y, so that's going to be 3, and that y is squared. Okay, so at this point, we've done our substitution. Now we're simply just going to remember from the earlier lesson to follow BEDMAS. Okay, so the first thing I need to do is my exponents, right? So I have negative 2 to the power of 2. Okay, I can type that in my calculator if I want, but that's going to give me 4. Okay, plus, we'll simplify this in a second, but let's do this exponent first. So 3 to the power of 2 is 9. Don't forget the sign, so minus 9. We can simplify this as well, right? We can do this multiplication as we're going left to right, because it doesn't, as long as we do this 9 first. So negative 2 times 3 is negative 6. All right, so now again, we're just going to keep following BEDMAS. 2 times 4 is 8. Okay, and I'm just going to write this as minus 6 because there's a negative and a positive sign. Minus 9. Okay, so 8 minus 6 minus 9 gives me negative 7. Okay, one last example here. A word problem. So this one says the volume of a cylinder is given by the formula V equals pi r squared h. Find the volume of a cylinder with a diameter of 5 centimeters and a height of 7.5 centimeters. Okay, So the first thing that I want to figure out is, or I'm just going to write out the information that I know. So I know my diameter is 5, okay? Remember, I need to figure out what the radius is because that's part of my equation here, right? I'm not going to sub 5 in because it doesn't say anywhere in here that I need the diameter. But remember, the radius is half of the diameter, okay? So my radius is actually 2.5. And my height was given to me is 7.5. Okay, this is actually just substitution because I have a formula, right? And I have my information. So all I'm going to do is sub that information into my formula and solve for V. Okay, so V equals pi. My radius is 2.5 squared, and my height is 7.5. Again, remembering to use BEDMAS here. So I have pi 2.5 squared is actually 6.25 times 7.5. And then again, you could do this all in one step, or you could break it down. So pi 6.25 times 7.5 is 46.88. Okay, and the last step there is just taking 46.88 and multiplying it either by using your pi button or multiplying by 3.14, which gives us that the volume is equal to 147.2 centimeters and cubed. So just as a side note, because we will need to know this eventually, volume is always cubed. Okay, and that was our last example.